Welcome to Dr. Jed's ongoing calculus video series. Today's lesson is section 3.3 from Rogowski, the product and quotient rules. Now, I'm going to give you the product and quotient rule formulas, and then we'll do some examples. First we'll do a product rule formula and then use it as an example. Then I'm going to give you the quotient rule, and we'll actually prove it. Then give an example, an easy example, and then a more complicated example using a rational function and finding a tangent line. So what we're going to do first is the product rule. If you recall, here's the product rule, but if you recall, when we added functions, the derivative of a function plus a function, you just added their derivatives. It was very easy. Same with subtraction, but it's not as easy with products, with multiplication. There are a lot of reasons for this, and the proof is in the book. You can read it if you wish, but the formula is the derivative of a function times another function. What you do is you say it's the derivative of the first one times the original second, not the derivative of the second, plus the derivative of the second times the original first. So f times g's derivative is the derivative of f times g plus the derivative of g times f. So let's do an example. We're going to do x to the fifth times e to the x. In order to do this, we have to identify one of them as f and one as g. And we often do this just by writing right below it. Here's f, here's g. So f will be the first one, and g will be the second. It actually doesn't matter. Multiplication is commutative, so we could consider this to be e to the x times x to the fifth if we wanted. We could switch them around. It doesn't matter. The formula is also commutative, so whichever way works better for you is fine. This is our f, though. This is our g. We need the derivatives. The derivative of x to the fifth is going to be 5x to the fourth. The derivative of g. E to the x is that function whose derivative is itself. So we get e to the x. Then we just plug them into the formula. We need the derivative of f times g plus the derivative of g times f. So the derivative of f, 5x to the fourth, times g plus the derivative of g times f. Now you could stop there, it is right, but there are a couple things that aren't really good about it. The first is, when you write e to the x times x to the fifth, it's a little awkward. Mathematicians put polynomials, which is like the x to the fifth part, in front of exponentials, because otherwise there's a little bit of mishmash between this exponent and this. And there's an e to the x in each of these that I'd like to factor out. So if I factor out the e to the x, and then use a parentheses to make it look a little nicer, what do I get? 5x to the fourth here, plus x to the fifth. When you talk about simplifying a function, the key is, does it look simpler? Is it easier to understand? So this top one versus this one. This one has only two things, whereas this one has kind of four things going on. This is simpler. We could also have factored an x to the fourth out of this. You'd pull there, and you'd pull it out of there too. There are times we'll want to do that. Right now I don't think it's going to be simpler, so I'm going to leave it like this. But there are times when that's useful. But we'll worry about that later. Now I'm going to talk about the quotient rule. But notice, first before we get to it, product has a plus in the middle. Quotient, which is division, will have a minus in the middle. But there'll be another catch to it. So let's take a look. The derivative of f divided by g, so it's f prime times g minus g prime times f. But because this is division, there's also a divide, and this is g squared. This is g times g on the bottom. Where does that come from? I'll show you. But first note, this one's not commutative. 1 over 2 is not the same as 2 over 1, so the order makes a difference, and you've got to be careful. It's f prime times g minus g prime times f. The order of these two is important, which one has the derivative where. There are some mnemonics to remember it, but the key is just find a way that actually works to remember it. What I'm going to do to prove this, first I'm going to write a little lemma. A lemma is a mini-theorem. It's a small little bit that doesn't stand out by itself, but is useful in other things, like proving another theorem. So what we're going to say is, suppose f is a function that has a derivative and is not 0, because if it's 0, you can't divide by it. So if that's true, the derivative of 1 over f of x, kind of like a quotient rule, but in a very special case, is going to be minus f prime of x over f squared of x. So the proof, we're going to go over here and do the proof. So what is this? Well, this is to remind us what we're doing. That's our goal. And then I want to find the derivative. How do I find the derivative? Well, I use the limit definition. Right now, we don't have anything else to work with, so that's where I'm going. And normally it's function at x plus h minus function at x divided by h. But the function here is actually 1 over f of x. So I need 1 over f of x plus h minus 1 over f of x, then over the h. Now this is a compound fraction. It's got fractions on top of another fraction piece, and that's a little awkward. But I'm going to worry about the top right now. I've got two different pieces. If I want to simplify that, I get common denominator. So I'm going to multiply by f over f here, and f of x plus h over f of x plus h here. I will end up with an f of x minus an f of x plus h on top. And then divide by each of those. The f of x plus h and the f of x. Then I'm dividing by h. So I've got something, divide by these, and then divide it again. When you do that, when you divide by something and then divide again, those are all on the bottom. So let me rewrite that right here. So this is the limit as h goes to 0. F of x minus f of x plus h divide by f of x plus h times f of x times h. I'm not done by any means, but notice these two here can be pulled out. Limits do have multiplication. The limit of something times something, you could pull them apart if they both make sense. I'm going to do that right away. And I get the limit as h goes to 0 of 1 over f of x plus h f of x times the limit as h goes to 0 still, f of x minus f of x plus h over h. Now, this first bit, as h goes to 0, remember f of x isn't 0, so it's fine. There's no 0 on the bottom. It's going to do great things. So that's f of x. This becomes f of x. We get 1 over f squared of x. This one is almost the definition of the derivative for f. The difference is the top is reversed. And how do you unreverse something? In this case, if this one should have a minus, that should have a plus. The way you fix that is by multiplying by minus 1. And then not to change it, we can multiply by minus 1 times minus 1. Or if you flip it, you pull a minus 1 out. However you do that, you're going to end up with minus f prime of x. So the final result here is minus f prime of x over f squared of x, which is what we were trying to set out for. Let's use that right here. What's the derivative of this? Well, it's this. We just need to know what the derivative of our special f on the bottom here is. And the derivative of 2 is 0. The derivative of c to the x, we talked about that, it's c to the x. So, the derivative of the whole thing is c to the x. So our answer is, this is equal to minus c to the x over quantity 2 plus c to the x squared. That's an easy one. They get more complicated. So let's do a slightly more complicated one. A rational function, perhaps. Oh, I got ahead of myself. Let's finish off with the quotient rule. I did the last one. So, f of x over g of x. The derivative. Well, in order to do that, I'm going to use the product rule. So I'm going to rewrite this. This is f of x times 1 over g of x. So what is the rule? It's the derivative of f times the second function. Normally we call that g, but here it's 1 over g. Plus the derivative of the second function, and this is where the lemma comes in. We get minus g prime of x over g squared of x times the first one. Now how do you finish that? Well, the key here is that we have fractions, so we want a common denominator. The denominator here is g squared, the denominator here is g. So we multiply this one by g over g and get the same thing. If I do that, I get f prime of x times the new g there, plus minus makes minus g prime of x, f of x, and everything then is over g squared of x. The benefit of the lemma is that we didn't have to get our hands dirty on this piece. We did the very specific little bits and then just used the product rule to finish it off. So let's now, to finish it off, do an example. Here's my example. I have a function, t squared minus 1 over t squared plus 1, and I'm going to take the tangent line at t equals 2. The curve, to finish this curve off, kind of does this. Right there's 2. The line should look something like that. How do you do this? Well, let's take this and work with it. F is our top part. G is our bottom part. We need their derivatives. T is our variable. So the derivative of t squared minus 1 is 2t. Likewise, the derivative of t squared plus 1 is 2t. There aren't a lot of variations in this one, but there are a lot of variations you can work with once you understand this rule. So what do we want? The derivative will be the derivative of, walking back here, the derivative of f times the derivative times the regular g minus the derivative of g times the regular f divided by g squared. So the derivative of f times the regular g minus the derivative of g times the regular f over the g squared. Now there are simplifications that can be done here, but what we want is a tangent line. We want when t is 2. So let's plug that in to find the slope. The slope is when t is 2. T equals 2, we get 2 times 2 is 4 times 5. 4 times 5 is 20 minus 2 times 2 is 4. This is 3, so minus 12 over 2 times 2 is 4 plus 1 is 5. 5 squared is 25. So what do we get? We get 8 over 25. Doesn't seem like a very glamorous sort of slope, but that's not important. What's important is we found the right one. So how do you find the line? Well, there's the line, but some number goes in there. How do you find that number? We plug 2 in for t. Then we have to figure out what the y value is at the right place. Plug 2 in here. I get 3 on top and 5 on the bottom. This is 3/5. How do I make that out? So this is 8/25 times 2 is 16/25. 16/25. What's this on this side? 3/5. How many 25ths is that? 5 over 5. That's going to be 15/25. So let's compare. There's 16/25 here. There are 15 here. The end result, to balance it out, we have minus 1/25. And there's our line. Now let's take a look at the curve. It's got a negative y-intercept. Not much of a negative. Almost 0. Take a look at the curve. Does that look like it's almost 0, but a little bit below the x-axis? Or, I'm sorry, the y-axis? That is. I think that works. What about the slope? This slope is significantly less than 1. So it's significantly less than this. And there you have it. Until next time, this is Dr. Jed's Videos.